In the last video, we talked about designing a ransomware resilient network. Not a network that promises ransomware will never get in, but a network that makes it harder for a ransomware to spread. And that brings us to a very important question. Can you actually see how it spreads? Because ransomware does not just enter your network. It moves from one endpoint to a backup server, to a file share, to something which is more critical. That internal movement is where east-west visibility becomes important. Because you cannot contain something which you cannot see. Welcome back to Beyond Uptime. In this video, we'll explain east-west visibility and why lateral movement is an east-west problem. And then I'll show a simple lab dashboard example of what normal traffic and suspicious internal movement can look like. Let's get into it. Most organizations are quite good at watching north-south traffic. That is the traffic moving in and out of the environment. Users going to the internet, customers accessing applications, branches connecting to a data center, workloads reaching cloud services. This traffic usually passes through obvious control points: firewalls, internet edges, VPN gateways, load balancers, cloud gateways, so we know it needs to be monitored. East-west traffic is different. East-west traffic is traffic moving inside the environment, endpoint to a file share, application server to a database, server to a backup system, identity system to an application, management network to an infrastructure. This internal traffic is what shows how your environment actually behaves. And once an attacker gets inside, this traffic is what they care about. Because attackers usually do not want to stay on first compromised machine. They want to move. That movement is called lateral movement. And lateral movement is an east-west problem. So rather than keeping this only as a concept, let's look at a simple dashboard example. This is not meant to be a full enterprise security platform. The point is to show the logic. Normal east-west traffic should look different from suspicious internal movement. And if we can see the difference, we can start turning visibility into assurance. You might remember this topology from the previous video. We demonstrated how segmentation policies on the SRX firewall were blocking unauthorized access between internal zones. The user network was isolated from the protected recovery environment, and reconnaissance traffic across those boundaries was denied successfully. But there is still an operational problem. Nobody wants engineers manually watching firewall logs. Even though the firewall is blocking the activity, traditional monitoring may still miss the bigger behavior pattern. So for this video, I've evolved the dashboard further. Previously, it focused on infrastructure telemetry, path quality, flow context, service assurance, and intent. Now, we have added another critical layer: east-west visibility. The platform can now detect suspicious lateral movement behavior between internal segments, without operators manually watching firewall logs. Right now, the environment is healthy. Segmentation is working properly. No suspicious east-west behavior is detected. Now, let's simulate lateral movement from a compromised endpoint. This system is attempting reconnaissance against a protected recovery segment. The firewall is still blocking everything successfully, but if you see the dashboard, It now recognizes abnormal east-west behavior patterns. Instead of waiting for a successful breach, it now detects the reconnaissance activity itself. And this is the difference between traditional monitoring and behavior assurance. Traditional monitoring focuses on uptime. Behavioral assurance understands context, repeated deny access attempts, segmentation boundary violations, and suspicious lateral movement trends. Now, I'll stop the reconnaissance activity and notice how the dashboard gradually returns back to normal, because the suspicious behavior disappears over time. Real assurance systems should understand behavior trends, not just trigger static alarms. Modern attackers rarely move north-south anymore. They move laterally. And if your platform only measures uptime, you may never see that movement happening. That's why east-west visibility is becoming critical for modern operational assurance. This is why east-west visibility usually needs to come before microsegmentation enforcement. If you do not understand the traffic, you're guessing. And guessing can create two problems. You either allow too much because you're afraid of breaking applications, or you block too aggressively and cause outages. The safer order is this: observe, map, validate, and then control. First, observe the real traffic. Then map the dependencies. And then validate what should be allowed. And then enforce your policy. This is how microsegmentation becomes safer. And this connects directly to ransomware resilience. Because ransomware resilience is not only about backups. Backups are critical, but by the time you're restoring anything, the business is already under pressure. A resilient network should make it harder for a ransomware to spread in the first place. That means limiting unnecessary access, protecting management interfaces, isolating backup systems, reducing flat networks, and detecting abnormal internal movement early. East-west visibility supports all of that. It helps you see whether the network is behaving according to the security design. And that is where visibility becomes an assurance. So the main takeaway is this: East-west visibility is about seeing internal movement. Not just what comes in from outside or what leaves your environment, but what moves inside. It helps you detect lateral movement. It helps you validate microsegmentation. It helps you reduce blast radius. And it helps network and security teams work from the same evidence. Because in modern enterprises, the real risk is not only what gets through the front door. It is what that compromised system can reach once it's already inside. And if you cannot see the movement, you cannot confidently control it. That closes phase 3 of this series, where we connected network assurance with cyber resilience. In the next phase, we move to AI infrastructure. And we start with a very important question. Can your infrastructure safely support AI before AI starts making decisions on top of it? Because if we already struggle to govern users, servers, applications, and service accounts, AI agents will make that problem much bigger. So in the next video, we will talk about secure your AI infrastructure before it secures you. If this video was useful, please consider subscribing. Thanks for watching, and and see you in the next one.